How do electricity circuits work? Have you ever wondered how the simple act of flipping a switch can light up a room? The answer lies in the fascinating world of electricity circuits. Let's break down how these circuits operate in a way that makes sense. An electrical circuit is essentially a complete loop made from materials that allow electric charge to flow. This flow is primarily made up of electrons, and we refer to it as electric current. To understand this better, think of a circuit as a racetrack for electrons. At the heart of every circuit are three main components. First, there is a power source, like a battery, which provides the electrical energy needed to get things moving. Next, we have conductors, usually wires, that carry the current around the circuit. Finally, there is a load, which could be a light bulb, motor, or heater. This load uses the electrical energy and converts it into another form, such as light or heat. For the current to flow, the circuit must be complete. If there is any break in the loop, the flow of electrons stops entirely. Imagine a water hose with a kink. No water can flow through it. Electric current flows from the negative side of the power source, travels through the conductors, and enters the load. Inside the load, the electrical energy is transformed. For instance, in a light bulb, the filament resists the flow of electrons, which causes it to heat up and emit light. Several factors influence how electricity flows through a circuit. Voltage, measured in volts, is the electrical potential difference that pushes the electrons. Current, measured in amperes, is the rate at which electrons flow. Resistance, measured in ohms, is the opposition to the flow of current provided by the load or other components in the circuit. Electricity tends to follow the path of least resistance. In circuits with multiple paths, known as parallel circuits, more current flows through the path with less resistance. Circuits can be arranged into common ways. In series circuits, components are connected one after another, so the same current flows through all components. In contrast, parallel circuits connect components across the same two points, allowing the current to split and flow through multiple paths at the same time. In a series circuit, the total voltage from the power source is divided among the components. However, in parallel circuits, each component receives the full voltage. Understanding how circuits work helps explain everyday devices, from simple flashlights to complex electronics. By knowing how electrical energy is directed and transformed, we can appreciate the technology that powers our daily lives.